Hey all, it's Catch here. In this Tidy Tuesday video, we're not going to be going over this week's data set. Instead, I wanted to work on a different type of project. Most of these videos are about like machine learning and stuff like that, but I thought it'd be an interesting video to do a Riddler problem, which David Robinson has done before. Basically, since it's getting to the end of the year, I wanted to start working on my own R skills. And one of the things I want to work on is basically writing more efficient code. And I was kind of wondering, like, how can I actually practice writing faster code and figuring out like where my bottlenecks are at? And I think that doing these types of Riddler questions is a good way to kind of like look at how you can speed up your code and also ways to just kind of approach different problems. So I figured this would be a good video to do a Riddler problem, especially since I think this Riddler question is pretty straightforward. It's the Riddler Express from December 4th. So I figured we'd make a video and kind of see how we would approach this. I'm just going to copy on this text, and then I'm going to go to an R Studio. I'm going to load in our Markdown, and I'm going to call this Tidy Tuesday Riddler, and I'll say December, because I might do more Riddler projects in the future. Okay. And I think for this video, I'm probably just only going to use the Tidyverse. I'm just going to load in the Tidyverse, and I'm going to paste this the actual question into the script. So from this is from Christopher Halverson from a bibliophilic game of Secret Santa. I have no idea what that word actually means. So, okay, every year, CJ's family of 5, including CJ, so I guess 5 people, do a book exchange for Christmas. First, each person puts their name in a hat, the hat is shaken, and then each person draws a random name from the hat and gives that person a book. Okay, so it's kind of like a Secret Santa thing. However, if anyone draws their own name, they all put their names back into the hat and start over. What is the probability that no one will draw their own name? Okay. So I think this is a pretty interesting question, because I think it's the actual function that we'll use is going to be pretty straightforward. So since we have like 5 people, and basically we're having something where it's like we're sampling without replacement, because when someone picks a name from the hat, it reduces to 4 available names, and the next person does it, and the next person does it, etc., until there's no name. And what basically we're trying to do is calculate the probability that no one will draw their own name. Okay. So let's actually do this where I'm going to just use the sample function. And with the sample function, we can enter in 5 times of size equals 5. And we can just specify replace is equal to false. So sampling without replacement. And then we can see it's 3, 2, 1, 4, 5. All right. So out of the 5 names, we basically sampled it 5 times without replacement. So we would expect to get all of the 5 names. And what I'm actually going to do is I'm going to use these like numbers, like 3, 2, 1, 4, 1, 2, 3, 4, 5 as like pseudo names, right? So 1 could be Jerry, 2 could be Joe, etc. And what I'll just say is, if the first person is 1, they're going to go up and they drew 3. The second person came up, they drew a 2. Since the second person drew a 2, we'll just say that he or she drew his or her own name, and that would be a fail, right? So how can we actually calculate the probabilities that no one will draw their own name? Well, this could be just one game right here. So this would be basically a fail. And I think what we could do is just basically use this function and just reiterate it multiple times and then calculate the probability using like the law of large numbers. Okay. So one of the things that we have to do is think of this as how we can write this in a very fast, efficient code. Because right now, this is actually very fast because it's vectorized and it's a base R code. So right now we're just saying like, oh, we drew it, we drew it again. So I just simulated like 3 times. But we need to check if these numbers match their indices. And how we can do that is we can actually do the equals, is we can just say, okay, so this sample right here is equal to, and we'll just say 1, 2, 3, 4, 5, right? So we have false, false, true, false, false. I'm actually going to first do this as a test. So I'll say first run, right? So that way we can just kind of like make sure it's not changing all the time. So we have our first run, 2, 3, 1, 5, 4, and then we can just check if they drew their own name, and we can see that they did not draw their own name, right? Because we can do a little sanity check, say 1, no, 2, 3, 4, 5, right? So that would be a perfect game where no one drew their own name, right? So we check that. And one thing that's kind of cool is we can just convert this to a as.numeric, right? Because they're logical, they're essentially zeros and ones. And since they're all falses, they're all zeros. And what I think we're going to do is, since we have to basically check if all of them are false, we can just say some of it, right? And if they're all false, it has to be 0. So then we can just say is equal to 0, and that's true, right? So this right here is essentially the game that we did. So what we can do now is just put this into a function. So let's actually create this. So let's just say try to replicate the process using sampling without replacement. And then say check. I'll say check if people drew their own names. So I'm just gonna say right there, right? And then I'll say count how many times a person how many people drew their own name, and then we could just say that and say check if no one drew their own name, right? So it kind of just went through the process where we said first let's just replicate the sampling, right? Then we say check if they drew their own names. Then we see count how many people actually drew their own name. Then check to see if no one actually drew their own name, or we're saying it's equals to 0. And now let's actually create this into a function. Since they're exchanging books, I'm going to call this a book exchange. Write a function right here. And there's going to be no inputs because we're essentially going to replicate the entire process. We're going to put this right here. We're going to check if it's equal to we're going to check if it's equal to their own name, if they drew their own names. And then we're going to sum it as .numeric. And then we're going to check if it's 0. Right? So I should probably just put it like that. And then put this thing right there. But they're the same thing. Cool. So right here is our book exchange. And we're gonna replicate it once, twice, 3 times, etc. So I could use a for loop for this, just do a for I in, and then just replicate that, put it in a list, and call it a day. But what's cool about R is they actually have a bunch of functions where we can basically replicate this function thousands of times. So I'm going to say convert, create function to use as a simulation. Okay, and that function is actually replicate. And this will basically say, like, given how many times you want to use this function, which is n, so we'll just say 100, and then our function will be book exchange. Oops. Book exchange, it just right. And now we have it replicating 100 times, and we have all this, right? So we have it. We have our values. One thing we can do is we can convert these to as.numeric again. So now there's zeros and ones. Where 0 is that they that they did not draw their own name, and then we can just say like mean, right? So what's the probability that they won't draw their own name? or what's technically the probability that they do draw their own name is 0.4, and then you could just say like -1 or the complement of it, right? And then be a 0.6. This is obviously probably not the right answer because we've only done it 100 times. But what we can do is actually simulate it multiple times. So I'll just say sim, and we'll just simulate this like 1, 1, 2, 3, 1, 2, 3, like a million times. And then we get our sim. So we can just subtract it, and we can see that the probability that no one will draw their own name is 63.319%. Okay, so that's pretty straightforward. But how can we do this in like a tidy way, right? So let's actually do this in a tidy way first. And with the tidy way, what I kind of like about the tidy way, even though we're sacrificing essentially speed, what we're getting is basically legibility, and we can do more sanity checks. So let's actually do that. One of the things that David Robinson does is he uses crossing. In this case, we can say like trials is equal to 1/100. And we can also say that we also want to basically simulate these people. So let's just call it, I guess, maybe draws is equal to 1 to 5, right? So we have that. What we can actually do now is just group by our trials, right? Mutate, and then what we're basically going to replicate is the rolling process or the sampling process. So just say let's call it res. So res is equal to a sample 5, size is equal to 5, replace is equal to false, right? And now we can see with our trials we have 1, like 3, 1, 4, 5, 2, 1, 3, 2, 4, 5, right? So we're just basically simulating the same thing. Okay. And what we can also do now is we can say we can kind of just do another logic. So we can say like Drew own name is equal to draws is equal to res, right? It's right there. Okay. And technically, if I wanted to make this a little bit faster, I could ungroup it and then mutate it. So mutate. So mutate draws. Drew own name is equal to draws is equal to res. Right. And then what we can do is count our trials. So for each simulation, we'll count how many people drew own name. Right. And then what we can say is maybe even do a pivot wider. So names from equals Drew own name, values from equals n, values fill is equal to 0. Values Drew own name pivot. Oh, spelled that. Right, so we're saying like count how many people drew their own name, and then we're gonna convert that to a wide format. And we're saying, okay, in this case, 5 people did not draw their own name, which means that is a success. In this case, 1 person had to draw their own name. So what we can do now is actually just do a count where we can say like count, count false is equal to 5, right? And then we can say, so we're basically doing a filter count or like a count if. And we say mutate n is equal to n divided by sum m, and now we have our proportions, right? Which if we see right now it's 0.7, 0.3. It seems like it's matching up with our probabilities. Now what we can do is actually simulate it, like say like I don't know 1,000,000 times. It's going to take a little bit longer than our other function, but let's see if it actually matches. Right, so 63.4, 63.3. Basically what we're expecting is that we have a 63% chance of us not drawing any of our own names. So that was basically it for this video. I know this is pretty quick and it's essentially just using sampling, but I think this type of weekly question is kind of a good thing to kind of work on. with addition to like we're analyzing Tidy Tuesday data sets, because it allows you to do a lot more problem solving with a goal. And you have to do a bunch of logic, stuff like that. And I think it's pretty fun. So hopefully I might have got the answer right, and I didn't misunderstand the question. But it still teaches you a lot of how to do like some optimization in your code, how you would approach the logic and kind of write it out in R. It's pretty fun stuff. So I hope you guys enjoy this video, and I'll see you guys next week, and tidy on.